You know, we use it every single day, but have you ever really stopped to think about it? Measurement. How do we make sure that 1 meter here is exactly the same as 1 meter on the complete opposite side of the planet? Well, it turns out there's a universal language for that, and that's exactly what we're going to dive into today.
So let's just start with a big question. I want you to imagine a world where every single scientist, every engineer, heck, even every cook, had their own personal way of measuring stuff. Why would that make progress, or even just daily life, pretty much impossible? Just keep that question in the back of your mind.
The answer to that question? Well, it's just one word: confusion. Total, utter confusion. Without a shared standard, our world would be pure chaos. And believe me, not the fun kind. Let me paint you a picture of what that might actually look like. Imagine trying to bake a cake with a recipe like this. How much is some sugar? A pinch? A handful? An entire bag? I mean, your cake would be a complete disaster, right? And so would any scientific experiment that had to rely on that kind of guesswork.
Or, hey, what about building something simple, like a shelf? Your idea of kinda long and my idea of kinda long are probably totally different. Nothing would fit, nothing would ever be level. It's not a reliable way to build anything.
And this chaos would just spill over into everything. Getting directions would be an absolute nightmare. How long is a while? Is that 5 minutes? An hour? You'd be lost all the time. Precision is everything, and that's exactly where our solution comes in.
So, to fight back against all this potential chaos, humanity came together to create a common language for measurement. The goal was simple: create a truly universal system that everyone, everywhere, could agree on and, more importantly, understand. And that language is the International System of Units, or as most of us know it, SI. It's basically the modern, souped-up version of the metric system, and it is, quite literally, the global standard for how we measure things in science, in technology, and in business. And that's why thinking of the SI system as a language is honestly the perfect analogy. It has its own alphabet, its own words, and a really clear grammar that lets scientists share their work with perfect clarity, avoiding all that confusion we were just talking about.
So if SI is a language, then it's got to have an alphabet, right? A set of fundamental building blocks. And it does. These are the 7 base units, and they are the absolute foundation for measuring our entire physical world.
Okay, so think about that for a second. To measure absolutely everything, from the distance to the farthest star to the weight of a single atom, how many of these core, fundamental units would you guess we need? 100? Maybe 1,000? The answer is just 7. That's it. And there's a real beauty in that, isn't there? With just these 7 fundamental units, we can describe and measure literally any physical quantity in the entire universe. It's kind of mind-blowing. And here they are, the magnificent 7. We've got the meter for length, the kilogram for mass, the second for time, the ampere for electric current, the Kelvin for temperature, the mole for the amount of a substance, and the candela for luminous intensity. Everything else, everything, is built from these 7.
All right, so now that we have our alphabet, we can start building some words. This brings us to something called derived units, which are what you get when you start combining these core building blocks to measure all the other stuff.
So let's stick with that language analogy. If these 7 base units are the fundamental letters, the A, B, and C's of the physical world, how do we start forming more complex ideas?
Well, we create what are called derived units. Just like letters combine to make words, these base units combine to measure more complex things like speed or force or energy. These are the words of our measurement language.
Let's take speed. It's a perfect example. We start with the base unit for length, which is the meter. Then we combine it with the base unit for time, the second. And what do you get? Meters per second, a derived unit we all use. It's that simple, that logical.
So it really all boils down to this. Base units are the fundamental building blocks. You can't break them down any further. Derived units are all the cool combinations you can create from those blocks, and they let us describe the world in much, much greater detail.
So let's bring this all back to our original question. Why does having this super carefully constructed system actually matter in the real world? What's the big deal?
It matters for 3 huge reasons. First, accuracy. It means we can trust the numbers. Second, consistency, which guarantees that a kilogram in Brazil is the exact same as a kilogram in Japan. And maybe most important of all, universal understanding, which lets scientists all over the world work together and share data without a hitch. I mean, without this shared language, modern life as we know it would basically grind to a halt. Every piece of technology you use, every international product you buy, every scientific breakthrough we celebrate, it's all built on this silent, universal agreement on how we measure things.
And that leaves us with a final thought to chew on. We've seen how a common standard, a universal language, totally transforms science from chaos into collaboration. It really makes you wonder, if it works so well for measurement, what other areas of our lives could seriously use a truly universal language? Thanks for joining me.